A new prep class was designed to improve SAT test scores. 4 students were selected at random. Their scores on 2 practice exams were recorded, one before the class and one after the class. The data is recorded in the table below. Are the scores on average higher after the class? So what we're saying here is higher score after equals good. Nice little shorthand notation here. Also note we are running this at a 1% level of significance this time. So that'll be used later on. That will be our alpha. Hey, why did I add this extra little note? I added this note because we are going to have to create our null and alternative hypothesis. Okay, it's very unlikely that, it would be thought ahead of time that this would make these scores worse in some way. So we're just going to say that the null is that it's equal to 0. There is no difference. The average difference isn't anything. All right, that's our null. Our alternative is going to be comparing the mu sub d to 0 still. But we need to tell, do we want this to be negative mu sub d? All right, well, mu sub d are before, minus is our afters, because that's how our data was displayed. It's the first sample minus the second sample. So let's pick one of these that was a quote unquote good result. All right, this person increased. That's good. We want their score to increase. This person increased, decreased. All right, so we could check any of the first 3. And again, we're really just looking, is it a positive difference or a negative difference? Because that's going to tell us if we want a positive greater than 0 or negative less than 0. So let's look at this first one. If I subtract these 2 right here, 1840 minus 1920, 1840 minus 1920 is equal to negative 80. If I subtract them, it equals negative 80. So negative difference is good in this case. Note that in our last example, positive difference was good. Here we want mu sub d to be less than 0. That's our alternative hypothesis. That's what we're trying to show here. Right, then I have to go and use my online calculator to get that p-value and that test statistic. All right, our p-value, oops, still got the last example in here. Let me backspace out of here real quick. All right, that was really fun. Maybe this will be quicker. All right, we are putting in our data this time, 1840, comma, oops, I'm in data 2. Glad I caught that early on. Why is this thing still here? Okay. 1840, comma, 1960, comma, 1920, comma, 2150. Again, make sure you do the same order for both 1920, comma 2160, comma 2200, comma 2100. And we wanted to show that the differences were less than 0. Again, if you are using the upper bound, lower bound, that confidence interval, I haven't discussed them and I actually won't really ask for them, but that's why we put in the confidence level here. All right, our t-score is negative 1.770, it looks like. And our p-value is 0.0874, 0.0874. Actually gonna move this down here. We're comparing this to an alpha of 0.01. Level of significance highlighted in blue right up above there. Okay, what's bigger? Let's go place by place. Both are zeros past the decimal. The next place is an 8 versus a 1. P is larger than alpha. If the P is high, the null is fly. This means our decision is that we fail to reject the null hypothesis. Oops. Our H naught. So as a conclusion, we still have to write our conclusion in context of the problem. At the 1% level of significance, 1% level of significance. Again, always important to note what level of significance we ran it at. We have insufficient or sufficient, enough or not enough. We don't have enough evidence here. We don't have the evidence to support. That's why we failed to reject. We failed our mission. All right. At the 1% level of significance, we have insufficient. We do not have enough evidence to support or to conclude. And here's where we're saying that the average difference is less than 0. Again, that sounds really odd. So instead, we're going to go back to what we were actually, originally asked. That the scores on average are higher after the class. That's what we were trying to show, and we don't have the evidence to support it. We're not sure that they are or aren't. We just don't have the evidence to support it. We have insufficient evidence to conclude that the student scores on average are higher after the class. That's what we were trying to show. Remember, chapter 9 and chapter 10, all of these conclusions are saying the level of significance, whether we have the evidence or we don't have the evidence, and then you're stating whatever you conveyed in that alternative hypothesis. Whether we reject H naught or we fail to reject H naught, we are still trying to show our alternative. We're trying to prove the alternative hypothesis. So you'll notice that it is that same kind of thing in all of our examples. All right, thanks for sticking with me through chapter 10. Here we go to chapter 11 next.